Why do we even care what the slope is? Who cares? Sorry, okay. This is pissing me off. I like spent time to set this up. Ah! It works! Okay. So this is what I remember, okay? Right? Slope of a line. It's like X and Y. And then there's like 0, 0, obviously, right there. Okay. Okay. Looks like boobs. Okay, sorry. Okay, 1, 2, 3, whatever. 1, 2, 3. Okay. So if I'm trying to find the slope of like a line, right? And say it goes through this point right here, and it goes through like this point right here, and it goes through like this point right here, and it goes through this point right here, okay? And I'm trying to find the slope, okay, right? What is the slope of this line, right? Why do we even care what the slope is? Who cares? Sorry, okay. So you use a simple formula, okay? The formula goes, okay? Sorry, it's just ridiculous. Okay, the formula is as such. Y, this is too big of a pen. Okay, here. No, here. Y, you can't even see that. Okay, Y equals mx plus b is the formula, where x and y are, uh-oh. I don't know if I know how to do this anymore. Okay, y is the, well, b is the intercept. Oh, shit. M has got to be, okay, there, this is it. So x and y, the slope, the actual slope, I believe, is m. Wait. Okay, hold on. So say that I have 2 points. Okay, so I know that this point right here is like 2, 3, right? We know that that is 2, 3, and we know that this point here is like 0, 1. So on the left is x and y. Okay, so 0, 1, and 2, and 3, right? So if I know that, then frick. I mean, I don't know if I remember this. So, no. Back in the day, though, I was really good at this. Like, this was my bread and butter. As in, like, I close my eyes and teach this. So, okay. So, B is going to be, oh, the slope formula. The slope formula is, oh my God, isn't it like difference? I just do the change in Y. Wait. I think it's y2 minus y1 over x2 minus x1, right? So then you just do like, and say this is x, say this is point 1 and point 2, right? So then you would do x and y. So then you'd have 3 minus 1 over, and then this is what did I say this was? 1? Okay, and then this is 2, so then 2 minus 0. So then it's 2 over 2 equals 1. The slope is 1. Screw this formula, you don't need it. Just do the rest. That is the answer. You're trying to get the derivative of the formula used to make the line. Right. Nah, what'd you say? Well, I know derivatives too. I actually know derivatives too. So let's clear the board, please. Can we clear the board? Okay. So derivatives, right. So derivatives are as such. So if you want to find the derivative of like something, can you guys see that? Where'd the pen go? Well, the app broke, so lesson's over. Hey, fun times though. That's not how my lessons went. I need you all to know I actually had good lessons back in the day. They were good. Oh, maybe because it's got to be a different color. Do you see this? Ooh. Okay. So derivatives are like this. It's like this. So if you have like 5x squared, the derivative of 5x squared a derivative is signified by what is it signified by? Integral. Integers? No. Oh, the derivative of this is, so what you do is you take this and you take this, right? And you multiply them. And then you subtract 1 from that. And then it's 10x1. So 10x is the derivative. That's all I remember. Everything else I do remember something else. So then the integral is a reverse derivative. So the integral of 10x is, I think this signifies integral, is 5x squared and then plus c, which stands for constant, like, because it can be whatever, because the derivative of a number, like, I don't know, of 1 or you know, do you know what I mean? Yeah. All right, cool. Next lesson. Oh my God. Why do I didn't even go to school. You know, like, why did I do all that? But what I was struggling with yesterday was just basic addition. Okay. I was struggling with this math problem. 143 times 1.5. Okay. So I can do it now. Okay. So what you do is you do like 5 times 3, 15, 21, right? Carry the 2 to 5, 2, 5, 2. Wait, what? 5, 6, 7. And then it's 0. And then you go 3, 4, 1. And then you add it together and it's 5, 4. And then this is where I got tripped up. The 7 plus 4, I don't know why I thought that was 13, but that's actually 11. And then you carry the 1 and then it's a 2. And then it's you put 1 decimal over, boom, 214.5. Following me? Question, how do you know if a number is divisible by 3? Ooh, that's a great question. I think the rule is if a number's last digit is divisible by 3, then the number is divisible by 3. Or you sum all the digits and I don't remember. Just use a calculator. Sorry. We should all learn math. It's important. Sum of the digits is divisible by 3. That's right. No. Sum of the digits. Can you repeat all that? No, I use so much brain power to recall that. It's crazy. It actually took a lot. 12 is divisible by 3 because 12, you add 1 plus 2 equals 3, and 3 is divisible by 3. So that's how you do it. Any questions? Who's ready for some geometry? This is a triangle. The interior angles of a triangle always add up to... Well, I believe 60 plus 60 plus 60, which is 180. So the angles of a triangle will always add up to 180. And if they are equal like this, and you signify them by like that, like this means that this is equivalent to this, which is equivalent to this. That means that this is a triangle with equal sides, also more commonly known as an equilateral triangle. Very good. 3/4. Very good. I cannot. Equilateral? I actually had it right the first time. I think it's equilateral. It's an equilateral triangle, okay? That's weird. Why is there an I in there? Because shouldn't it be like equilateral? Because like equal? Whatever. Okay, so that's confusing. So that's an equilateral triangle. So there's other kinds of triangles. They don't get as much love, but here's one, and it's called an isosceles triangle, like this. All right. So an isosceles triangle is signified by 2 sides being equal and then a third that's not. Oh, I'm inside of the isosceles triangle. But it follows the rules of a triangle because that's gonna be okay. Angle A, B, and C, okay, signified by A, B, and C, all equal 180 degrees. Holy shit, I actually remember like the way, like signing it, you know? I haven't written this stuff in 15 years. My brain is like breaking. It's kind of insane. Am I doing this right? Wait, Leslie, you are the acutest streamer. Okay, speaking of acute, let's go over acute and obtuse angles, okay? So this is a right angle, okay? And it's because this is a 90-degree angle, and we all know what like 90 degrees is, right? But what happens when, you know, somebody comes here and pushes, okay, the angle out, okay? So now we have an angle. Yeah, they push, okay, with force. Force equals mass times acceleration. Any knowers? We're mixing a little physics into this. Okay, so the angle will break, okay? pushes, and now we no longer have a right angle, but we have an obtuse angle. Some of you may have been called obtuse in your life, okay? This is a different kind of obtuse. Obtuse, this is a different kind. This is when it's like greater than 90, okay? This is also an obtuse angle, here to here, okay? So basically anywhere from a straight line, which is 180 degrees, which familiarly, remember a triangle, they add up to 180. Well, the line, a straight line is also 180 degrees. So if you take two 90 degrees, you add them together, what do you get? 180. Big, okay? So anywhere from 90 to 180. So greater than, okay, between 91 and 179 equals obtuse. Straight line isn't obtuse, right? Okay, great. Now what happens when instead you have the guy come around, right? Here's the 90, and he pushes this way with force. Force equals ma, mass times acceleration, okay? This way. Well, the angle now goes in. And this is what the chatter was saying about me. Acute. Thank you so much. That is an acute angle. Okay, so it's like, you know, it's kind of easy to remember because like cute. It goes like small, cute, you know? So that's an acute angle. And so that is geometry. I know we started with triangles, but somehow we got to angles. I got distracted, but that's kind of all you really need to know in geometry. It gets a little bit more complicated with like, I don't know, it gets like weird. There's